One of the characteristics of Alkanol is combustion. That means Alkanols can catch fire. That is what it means. Alkanols can combust. And when a substance catches fire, it means that it combines with oxygen to form primarily water and carbon dioxide. So that is what Alkanol does when it catches fire. So when Alkanol is burning in fire, two products are formed, water and carbon dioxide. But there are three scenarios in this combustion: insufficient oxygen, insufficient oxygen, insufficient oxygen. There are two compounds formed, water and carbon dioxide. Because this is actually oxidation reaction, where oxygen is added to the Alkanol, to the carbon in Alkanol, to form an oxide, carbon dioxide. But in insufficient oxygen, two things are possibly formed, water and carbon dioxide. Here, it shows that the oxidation is not complete. Instead of having carbon dioxide, we have carbon dioxide. Now, in another scenario, we have in extremely insufficient oxygen, we have water and elemental carbon. You see? So, but sometimes when a reaction takes place in insufficient oxygen, a combination of these two may occur, where we have both carbon monoxide or carbon dioxide and elemental carbon formed. So let's represent this using hexanol. Hexanol is C6H13OH. C6H13OH. When it burns in oxygen, we have water and carbon dioxide. That is hexanol combustion. To balance the equation, carbon is 6 here. We come here and write carbon. Write 6 at the back of carbon. Hydrogen is 13 plus 1. That is 14. To have 14 here, we write 7 at the back. Oxygen is 1 plus 2, 3. And 7 plus 6 times 2, 12. 12 plus 7 is 19. To create 19 here, 1 is already here. Remaining 18 here, we write 9. So this is complete combustion. Complete combustion. In incomplete combustion, where carbon monoxide is formed, we have C6H13OH plus O2 to afford H2O plus CO. Carbon is 6. We also write 6 at the back of CO. Hydrogen is still 14. We write 7 at the back of water. And oxygen is 3 at the reactant side. 7 plus 6. 13. So to create 13 here, 1 is here already, remaining 12 here. To make 12 here, we write 6 at the back of oxygen. You see that in the two reactions, the first reaction actually shows that there is sufficient amount of oxygen, 9 volumes of oxygen used to combust this hexanol. But here, the oxygen reduced to 6 volumes. That is why we have an incomplete oxide of carbon, which is carbon monoxide. So that is incomplete combustion. Or in the presence of insufficient oxygen. This is insufficient oxygen. But there is a scenario extremely insufficient, where we have only carbon, elemental carbon present. So we write that from the equation C6H13OH plus O2 to afford H2O plus carbon. So carbon is 6 here. We write 6 at the back of carbon. Hydrogen is 14. We write 7. Oxygen is only 7 here. So coming here, we have 1 here, remaining 6. We write 3. You see that the volume of oxygen has dropped from 9 to 6, from 6 to 3. Extremely low. That is why we have elemental carbon here. This is extremely insufficient oxygen. Extremely insufficient oxygen. Now, there are sometimes we have combination of carbon monoxide and elemental carbon in an insufficient amount. We can have this C6H13 OH plus O2, where we have water plus carbon monoxide plus elemental carbon. To balance this equation, we can decide to write, we have carbon 6 here, we can decide to write 5 here. Write 5 here, plus 1, 6. Then oxygen is 1 plus 2, 3. 1 plus 1. Okay, 1 here, you write 2, will it work? 2 times 2, hydrogen is now 4. Okay, let's decide to write that 5 here. So that carbon is 5 plus 1, 6, balanced. Now, hydrogen 13 plus 1, 14. Coming here, you write 7, balanced. So now, after balancing hydrogen, oxygen is now 1 plus 2, 3. And here, 7 plus 5. And that is 12. To make here 12, 1 is here already. Remaining 11. That 11, there is no whole number that will multiply 11 to get 12. I'll multiply 2 to get 11. No whole number. So you write that 11 here, divided by 2. In order to clear this fraction, you multiply everything by the denominator 2. 2 times 1 here, you have 2C6, H13, OH, plus 11 over 2 times 2 is 11. 11 O2, to avoid 7 times 2, 14 H2O, plus 5 times 2, 10. 10CO, plus 1 times 2, 2C. We now check if it is balanced. Carbon is 6 times 2, 12. We come here, carbon is 10 here, plus 2, 12, balanced. Hydrogen is 13 times 2, 26, plus 1 times 2, 2. 26 plus 2, 28. We come here, 14 times 2, 28. So hydrogen is balanced. So we come to oxygen. Oxygen is 2 here, plus 11 times 2, 22. 22 plus 2, 24. Oxygen here is 14 plus 10, 24. So it's balanced. What we are saying is, in sufficient amount of oxygen, there is complete combustion of the hexanol to give water and carbon dioxide. It's not only hexanol. Any alkanol in sufficient oxygen bonds to form water and carbon dioxide only. But in insufficient oxygen, we have, instead of having carbon dioxide, we have carbon dioxide. In extremely insufficient oxygen, instead of having that carbon dioxide, we have elemental carbon. Practically, this reaction and this reaction may not take place where only carbon dioxide or only elemental carbon is formed. A combination of the two may be necessary in the reaction mixture. That is why we created this equation where you have only carbon dioxide and elemental carbon and water present in the product mixture. Thank you very much for watching. Next time we will look at applications of combustion reaction.